Hey everyone, welcome back to another year of Bioengineering 325. It's really great to be back, and thank you all for watching this video for help on Homework 1, Question 5. So let's jump right into it. So we always start off by reading the question using the geometric relations given below, and that should say the chain rule, not chair rule, chain rule for differentiation, show the following. So we want to show this. So this is our end result. And looks like these are our relations. Great. So let's first recall what is the chain rule. Some of you may already be familiar, but the chain rule is we say dy dx is going to be equal to the derivative of y with respect to some function u, right? Times du over dx. And what that does is essentially we can cancel these and we'll still get dy over dx, but it allows us to solve for something else, some function u, some function u. So in related to our context, we can clearly see that we need to find right over here the partial derivative with respect to x and the partial derivative with respect to y, right? So let's just write that out. So we have d dx is equal to blank, and we have d dy. So this is what we're expected to derive through using this chain rule. So right away, we can already know that, well, since this is in the numerator, and we saw it here, and this is in the denominator, right? We're going to expect some function u to be a part of this. So let me just write out this first part for the d dx. So we have a partial derivative, that's our numerator, times something in our denominator. Well, what do we think? Well, it looks like we can see clearly from just the answer, we're doing it with respect to theta and with respect to r, right? So for that to be in our expression, that means we need to have a theta, right? And likewise, we need a d theta up here as well so that it can cancel out and result in d dx, right? But that's not all. We also have our r component for both the x and y. And this makes sense. So what we're going to do is also include the r term. There we go. So essentially, this will all simplify back out to d dx. But this uses the chain rule to find now this end result. So let's keep moving forward, and I want you to try for this one right here, okay? So you're going to start out with this. Then, now, we talked about earlier some function u, right? Some function u that we can derive, right? So what would be that in this case? Well, do we have some function theta, or do we also have some function r? Well, let's take a quick look at the prompt and you will see right away here we go. We can use these to determine the derivative, right? Partial derivative of theta with respect to x. And the partial derivative of r with respect to x. Remember, this is actually written out. It looks like this, right? So please keep that in mind that we are taking the partial derivative of some function r with respect to x. In this case, at least right over here, okay? So let's actually do this out right now. So let's find what is r. Well, r over here is, actually it's given to us that r squared is equal to x squared plus y squared, which means, let's switch to black, r is equal to x squared plus y squared to the power of 1/2. Makes it easier when we take the partial derivative, right? So when we take the partial derivative of r, we get, right, power rule, bring that down. So we have a 1/2 times 1 over x squared plus y squared. to the 1/2, negative 1/2, but it's inverse. So now it's positive in the denominator, times, and here's the key part, right? We have this over here. We have x squared plus y squared. With respect to x, we treat the y as a constant, and x squared becomes 2x, right? So let's remember how to do our partial derivatives. That's a really key part in this course. So 2x, and well, would you look at that? The 2's cancel. So we have d dx or dr dx is equal to x over x squared plus y squared 1/2. And well, we're not going to just leave it right here like this, right? We can take a quick look at the answer key. This is the answer key, right? This is our end result. And we can see that it's in terms of theta, right? Sine, cosine, r. So it's in polar coordinates. So that's a hint that, well, let's use our polar coordinate relation. So we know x is equal to r cosine theta. So, and we also know, you should know this, also shown at the top, x squared plus y squared is equal to r squared, right? So from that, we also know that's just r, right? R is equal to the square root of x squared plus y squared, right? So we know that this is actually going to be r cosine theta over r. And look at that, the r's cancel out. And that leaves us with cosine theta. So with this result, right, this is 1 out of the 4 we need, because let's take a look back here. Super, super messy here. So let's actually just rewrite this out really quick. So we just found dr dx, right? We found that it was cosine theta. So we can substitute that in for cosine theta here, right? And let's double check our work at the top. Well, would you look at that? We have cosine theta ddr and cosine theta ddr. So we already have that right hand side done. That means we have to do the same thing for this left hand side as well as our y terms, right? So you should be doing this 4 times. 1, 2, 3, 4. And that's going to be how you show that actual derivation and getting to this result. If you have any questions, please always come to office hours. Always happy to help, and have a great day.